Hey everybody, this is a video for my 40S pre-calculus math students. I just wanted to do a few more examples of the stuff that or do some examples from the stuff that I assigned, because I know this stuff is kind of tricky. It's dealing with 6.1 and 6.3, and even a little bit with 6.2, which we're going to do some more examples for in the next video. But before we get started, take a look at all those things on the left here. What would you say about all of them? Well, for all of those things, I'll give you a sec, pause the video to think about it. What do they all have in common? Well, to a mathematician, none of those things are in simplest form. The simplest form for this would be, of course, 1/2. The simplest form for this is somewhat counterintuitive. Remember your grade 10 and 11 math. You multiply this by 1, which turns this into 2√3/3. I know that doesn't look simpler than this was, but to a mathematician it is, because the radical is out of the denominator. This one here looks, well, doesn't look like there's much I can do with it, but again, to a mathematician, this is the same number but simpler, because I've factored the root of 25 out of the radical. And then this guy, I don't want radicals in the denominator, and I can add fractions. I just have to times this by √2/2, and times this by oops, I meant to say √3/3, and this by √2/2. Sorry, I was getting ahead of myself there. So that's going to be √2 plus √3 all over √6, and even that isn't simplified because we don't want a radical in the denominator. So we do that, right? And then we keep going. So that's going to be √12 plus √18 all over 6. And we're not done there, because I have perfect squares in there that I can factor out. So I can take a 4 out of there, making it 2√3. I can take a 9 out of there, making it 3√2. And what do you notice there? I mean, what do you think? Is that the simplest answer, or could I simplify it even more? Now there's that one's a bit tricky, because think about it. You can cancel the 2 out of the 6, but you can't cancel a 2 out of here. Do you split it up and say that it's √3/3 plus √2/2, which is what I could have got if I'd have gone back to the beginning and just rationalized the denominators and not put them together. So which is the more simple answer? Actually, to a mathematician, we'd probably go with this. So, simplification can be tricky. Now let's talk about simplification. Oh, I don't know what hang on. I don't know what that's all about. Now let's do some simplification with trig. All right. Let's see. So this was what I assigned you, and I've had a couple people message me saying I'm really having a hard time getting the answers from the answer key on this. So let me just do a couple. How about I'll do 2C? Why don't we start there? So for 2C, all right, 2C, first copy it right. Sine squared x over cos squared x plus sine x cosecant x. All right, I think the first thing I'm going to do is simplify cosecant x and see what it looks like after that. Sine squared x over cos squared x plus sine x, and cosecant is 1 over sine. Aha! Those cancel and make a 1. So I'm looking at sine squared x over cos squared x plus 1. Now again, you might look at that and go, well, that's as simple as it can be. Well, yes and no. There's things I can do with that. For example, I know that sine squared plus cos squared is actually, let me say that again. Sine squared divided by cos squared is actually tangent squared. Okay, interesting. And tangent squared plus 1, that should look familiar. If you go back to your notes, and I should have had this ready before I started my video, but I wasn't thinking that far ahead. If you go back to your notes, there it is. Remember that tan squared plus 1 is actually equal to secant squared. So there we go. That might be the simplest answer, and I think that actually is the answer in the answer key. Let's double check that and make sure that I'm not making that up. let's see, there's the answer key. So that was 2c, and yes, that's the answer, secant squared. By the way, that's not the only way I could have got the answer. I'm just going to go back here in time. What if at that step I hadn't noticed the sine over cos was tan? Could I have still gotten the right answer? And yeah, I could have. I could have just taken this in a different direction. I could have said, okay, at this step here, instead of doing that's tangent, why don't I add those two things together? And the only way to add a fraction to something is to have a common denominator. Get it? I multiplied this 1 by cosine squared x over cosine squared x so that I have a common denominator. And then I have a common denominator. And once again, look where I'm at. Do you notice what you can do with that? Once again, back to my page of identities here. Our first and most famous of those identities, sine squared plus cos squared is 1. That is replacing this with 1. And then that's equal to secant squared of x. So either I notice that those two things make tangent, and then I remember that that is an identity, or I notice that once I add these together, this is an identity, and that's secant squared. Notice the common theme in whichever way I do it is that you have to notice things. That's really kind of the most important mathematical skill here, is to be able to notice when one thing is equivalent to something else. That's really important when doing these. You know, I actually want to go back to the last video I did. Remember the last video I did? I actually goofed this one up. So there's another something that we can talk about here. I'm just going to quickly go through this again. I'll show you where I goofed it up. I turned this one into sine over cos, because that's tangent, times cos over, and secant is 1 over cos, and cotangent is cosine over sine. And then I realized that this numerator times this fraction with that denominator, or this divided by this, is 1. This divided by this is 1. And then I just goofily went this divided by this and said, oh, therefore it's 1. In other words, I canceled those two things. Those two things don't cancel. I'm going to say it was late and I was tired. There we go. That's going to be sine theta times sine theta, right? Because when you divide by a fraction, you times by its reciprocal. So this actually simplified to sine squared theta. So go back in the notes from the last lesson, and if you just copied it down assuming I don't make mistakes, well, you assumed wrong. So go back and fix that. And then let's go back to this page. What do you think? What should we do now? Is that good enough for simplifying? Let's maybe let's try F, and then we'll say number 2 is done. Okay, so I'll do one more, 2F. So let's do 2F. So 2F says 1 over secant squared x plus 1 over cosecant squared x. And okay, once again, I have to start thinking, what does it mean to simplify this? Well, I guess it means to add them together. But I think before I add them together, I'm going to simplify them in terms of turning them into sine and cosine. So this is 1 over cosine squared of x, and this is 1 over sine squared of x. And then I realize, wait a minute, dividing by a fraction is the same as multiplying by the reciprocal. That's not 1 decimal, that's 1 times. There, times. All over 1 plus reciprocal of that, and timesing by 1 doesn't matter. So look what I get. And once again, you have to recognize what that is. Cool. Would I have got that if I'd have gone the other way? If I hadn't switched these to sine squared and cos squared, and I'd have instead done a common denominator, would I have gotten it? Probably, but this was the more efficient way. It took less steps. That's another important thing, is can you figure out the efficient way to get to what you want to get to? In this case, this most simplified answer. So that was 2F. I think that's good for number 2. If there's any others that you're completely stuck on in the first part of this page, by all means, come and check out the live chat. You can ask me there, or or we could set up a Teams time to meet, and I can show you how to do it. But let's do one like number 4. So we have to now do a verify, where we actually plug in this value into the expression. So let's see what that gets us. So the expression is cosine, or actually it's an equation, cosine of x over secant x minus 1 plus cosine of x over secant x plus 1 equals 2 cotangent squared of x. And I want to prove that that's true if x equals pi by 6. Well, I don't know about you, but I don't have secants and cotangents memorized, so I kind of have to go to my unit circle here and just make sure that I get this right. So on the unit circle, where's pi by 6? Right there. What is the fractions for pi by 6 in the coordinates? Well, it's root 3 over 2 for x and 1/2 for y. With me so far? So that's x and that's y. Now, let's think about this. Cosine is x, so this numerator is root 3 over 2. The denominator, secant, is the reciprocal of x. So this is going to be 2 over root 3 minus 1. Okay. Cosine, again, is root 3 over 2. And secant, again, is 2 over root 3 plus 1. And then over here, cotangent, okay, well, first of all, tangent is sine over cos, so cotangent is cos over sine. So let's figure out, or we'll just use some scrap paper over on the side here. What is the cotangent of pi by 6? Well, it would be the x over the y, so that's root 3 over 2 over 1/2. That is root 3 over 2 times 2 over 1, which is just root 3. So this is going to be 2 times root 3 squared. Get it? Because it's squared, cotangent of x. So, now what do we do? Well, this side is nice and easy to figure out. Root 3 squared is 3, 3 times 2. The right-hand side, 6. Let's do some arithmetic on this. Okay, so this is the square root of 3 over 2, and I'm going to have to get that into a common denominator. So I'm going to times the top and the bottom of this 1 by root 3 over root 3. So this is now 2 minus root 3 all over root 3. Here, I'm going to do the same trick. So the top stays the same for now, and the denominator is going to be, again, timesing this top and bottom by root 3 over root 3. This is going to be 2 plus root 3 over root 3. I know, this looks way more complicated than it did at the start when it was just cosines and secants, but it's getting somewhere. I am going to now, I can't just add those together because these notes, they're close, but they're not exactly like terms. So they're not a common denominator. So I'm going to actually maybe turn this into not a complex fraction, simplify the fraction first. So that's the numerator times the reciprocal of the denominator. So that's root 3 over 2 times root 3 over 2 minus root 3. And I'll do the same thing to this side. So that's root 3 over 2 times root 3 over 2 plus root 3. And all of this we have to prove is equal to 6. And we're not allowed to use a calculator. So if I'm timesing these together, you times fractions by going top times top and bottom times bottom. And I'm just going to leave this in factored form. And once again, top times top and bottom times bottom. Okay, what is the common denominator here of this mess? I'm going to have to, again, I got to make this all one number, and that one number had better be 6. Well, let's see. What is this going to be? I am going to say that the lowest common denominator is 2 times 2 minus root 3 times 2 plus root 3. So this side has to be times top and bottom by 2 plus root 3. So it's going to be 3 times 2 plus root 3 plus 3, and this one's going to get times top and bottom by 2 minus root 3. All over, and the common denominator is 2 times 2 plus root 3, 2 minus root 3. And that had better equal 6. I'm running out of room, but let's keep going. Okay, so this is going to be 6 plus 3 root 3 plus 6 minus 3 root 3. All right, so there's the top. The bottom, I'm just going to leave the 2 here for now. And remember that those are conjugate pairs, so they're going to make a difference of squares. They're going to make 4 minus root 3 times root 3. And look what's happening there. That cancels that. 6 plus 6 is 12. 4 minus 3 is 1, times 2 is 2. And there it is. Sorry, I had a room there a little bit. Neat. I like these. These are fun. So, that's the toughest things I assigned in the 6.1 assignment. The other thing I told you you could get working on is this exercise 15 page here. And I'll make another video where I go over a couple of the tougher problems from here. And, that's not very good. Okay, I don't know why this is not working the way it's supposed to. All right, anyway, I'll figure out my camera. And I'll post a video with this, this exercise 15 page. Thanks for watching, guys.